Sunny day and pwn.college. Let's get all set up. Get on Twitch. Follow along with the lively chat. Awesome. And then let's just tell everyone we are live. Let's see what's going on. All right. So, welcome welcome back. We got a report in the Twitch chat that I convinced someone to get some tea from the New Mexico tea company. That's awesome. If they were sponsoring us somehow, that'd be even more awesome. But yeah, it's great. I am in fact steeping some tea right now from the New Mexico tea company. I'm also eating a Baby Bell. It's Baby Yon snacks, but I steal them. It's like taking cheese snacks from a baby. All right, so let's get started and talk about memes at first, and then we'll talk about reversing. All right. I forgot to load the slides. My bad. All right, memes. So we're in week 7 of the semester. We're about halfway. Well, we're not quite about halfway through. I think I counted weeks kind of weirdly. But we're probably 40% through the semester, and getting close to halfway through the material. Halfway, of course, will be Toddler 1, which will be super exciting. In the meantime, let's look at some memes. Of course, class is still remote. Right when I got better from the last virus that my daughter infected me with from her daycare. Of course, she got better too. She went back to daycare. She caught some other virus. Now everyone is sick again and waiting for the COVID results this time around. So yeah, Baby Bug is keeping us remote, but that's okay. Everyone loves Twitch, and it's all good. All right. What other stuff is going on? The other thing that's going on is there is no baby mem today. The original schedule, we were going to launch the memory corruption module today, but that is being delayed to Thursday, and instead we're extending the reverse engineering module. I know some people are heartbroken because they were very excited to start on the memory corruption, and you might say, well, what is why did we extend it? We extended it because of this, because Baby Rev turned out to be a little harder. Well, no, it's not harder than expected. We expected it to be very, very hard, and I tried to convey that, but it is harder than let's see, harder than is reasonable for a 1.5 week module. So it becomes a 2-week module. It also, I think, is in a bad time at ASU's semester, where there was a lot of midterms and projects due around the same time. So hopefully 2 extra days will help. I especially like this and these kind of flashback nervous module memes, because yeah, Baby Rev 18 and Baby Rev 19 are very, very good slight twists on the reverse engineering. I think it's very fun stuff. Of course, 16 to 19 is the full Yan 85, and I encourage you, don't give up, push through. It's very fun. Type 2 fun, which is fun in retrospect, but not while it's happening. So this was too great a meme not to include, but the Baby Mem problem set drop is going to be on Thursday, and this meme will be back. Then to usher in the Baby Mem problem set, along with any other Baby Mem problem set memes you might have for us. In the meantime, of course, as I already said, I was waiting for my tea to steep. I think it has now steeped today. Oh no, I'm not gonna do the fake sponsorship again, but yeah, this is good stuff. Oh, why not? Maybe you're interested in what tea I'm drinking. It's definitely worth getting. If you're interested in, ooh, they have cool cups. If you're interested in the tea that I'm drinking today, I'm drinking this new Vithanakande Ceylon. I'm sure I mispronounced the Vithanakanda, but it's super good. It's very impressive tea. I'm a big fan. There again, New Mexico Tea Company isn't paying me to say this. They just make good tea. I actually once went to Albuquerque to go to their store and buy tea in person. There's pretty good stuff. Anyways, back to the memes. Oh, nice. So Liquid HDD on Twitch said that's the one that they got. It's very good. Highly recommend it. All right. Last year, if anyone was here or remembers, I drank frappuccinos in class. Maybe I'll bring that back. Frappuccino, or not frappuccino, what am I saying? Frappes. I got confused by the Twitch chat. The Twitch chat convinced me that I was drinking frappuccinos. But no, I was drinking frappes. It's a Greek coffee drink made out of instant coffee and like blended. It's super good. Maybe I'll bring that back. But the problem is you have to keep stirring it, and it has ice, and the ice makes a lot of noise, and you can look at videos from last year for it. It was a minor disaster in that regard. Anyways, and that's all the memes we have for you today. We got Hydro Homies in the chat. I have water as well, of course. I used to drink just enormous amounts of tea with no water, but you know, 1 or 2 times passing out from dehydration, you learn your lesson. Oops, I moved the wrong thing. No. Okay. No. God damn it. Hold on, I'm trying to move my... Okay. So, what's the current state of... There we go. Current state of the scoreboard. Well, the top of the scoreboard has all been filled up now, the top 20, with people that have 100%ed the current modules, including Baby Rev. So that's awesome. Great job, everybody. Of course, you'll have to wait until Thursday to see this scoreboard shift, but it will shift. It'll be fun stuff. And that's when you will start corrupting memory in earnest. So congrats everyone up here and everyone on the scoreboard at all. It's a lot of tough chows, and it's great to see everyone pushing through them. Of course, this module, we have a worldwide student, BUB, as the overall number 1. ASU takes spot number 2. It's okay. This is a good worldwide friendly competition. All right, let's keep rolling. What happened with CTF this weekend? 4 students played. My reading of the situation is that the rest were busy with baby ref, which makes a lot of sense, or with their other things. Again, as a reminder, you get 1% extra credit on your final score and your final grade in the class for every weekend of CTF. So don't forget about that. Those 4 students that played on 2 teams, so that's why I bolded that you should be playing CTFs with 4, at least 3 other people, please. Those 4 students solved 6 challenges, unique challenges between all of them, which is super awesome. When you start kind of breaking through the 1 challenge per person per CTF barrier, it's pretty good. Oh, okay. Janice is saying that not everyone was able to do stuff. You can still write a write-up. If you spend 8 hours in a CTF, even if you don't solve anything, it's 8 hours or 1 non-trivial solve. So submit write-ups. Don't leave extra credit on the table. All right. What else? Helpfulness. So we've gotten through enough of the semester now that I can start reasoning about how to award helpfulness points. Things are a little interesting because some of the most helpful people aren't actually ASU students. So obviously Charco's points will fizzle in the ether, I guess, or maybe they can donate them to ASU students and we'll figure out how to make that happen. But in the meantime, what I've done is I've mapped out the raw amount of things. So this is just everyone's things sorted. We have kind of the expected exponential curve that you always see with a long tail. This over here is 1 thanks point. People that have been thanked once. This is like, PyPy's 139. And the exponential in between. And what I did, I took basically more or less a log base 2 of the thanks, and then I scaled it from 0 to 100. And Charco says that they're willing to donate their points. So maybe we'll set up a donation system where everyone that's helpful can donate to increase the score of all the ASU students. That might be good. It's an interesting idea. All right. Anyways, so that's the current situation. I know initially we said we'll do something like PageRank, but it's just impossible to figure out a reasonable way to do that doesn't require an enormous amount of custom coding and so forth. It's going to be hard enough to figure out the meme extra credit. I actually assign those points. We will, but so thanks is going to be a much simpler system. The PageRank idea was there really to reduce abuse. People like just chain thanking each other. That hasn't been happening, so this I think is good. So this means that because it's a log base 2 scale, this means that early on in your thing and your helpfulness, you can really boost your score. So helping people once gives you, I don't remember, this will equate to probably 1% to you for your final grade. This will equate to probably 3, well, much more, right? So maybe 10%. So that's thanking twice, thanking 3 times, and then it gets more and more gradual, or being thanked. So keep helping each other. It seems that the helpfulness that everyone's exhibiting feels to me like a big part of the success of this year. I'm very happy that we really started encouraging collaboration instead of discouraging collaboration in that way. So it's cool to see. Keep going. Awesome. All right. The schedule, of course, we extended reverse engineering. Last year, reverse engineering was 2 weeks. This year, I was thinking hopefully we can do it in a week and a half. that wasn't the case. So what's the implication of that? The implication of that is, unfortunately, microarchitectural security is not going to happen this year. I think it was very optimistic. There's a lot of material in this course, and stuffing in an extra microarchitectural module was already very wistful thinking. The one thing that we could do is stick it here instead of advanced exploitation, and start advanced exploitation later and have it run into finals week as a final. I am hesitant to do that because I think there's already a lot of material, obviously, and people really need these last 10 days or so to go back and make up prior missed challenges. So most likely we will keep the microarchitectural stuff until we split this class into 2 classes. That'll be how we that will be how we roll with that. Let's see. Oh, graph on who has given the most things. I don't know how to do that. Well, I mean, we'd have to write code to figure out, you do this with Discord's API. Anyways, that was a Twitch question. So that the current schedule is more or less what last year was like, without the baby auto at then, giving more time for the advanced exploitation module. All right. So let's dig into how people are doing. You can see baby rev. This is the current scores if the module had really ended at 4. So these are the scores as of 4 p.m. It's all over the place. And if we look into the and it's actually, you can see embryo GDB, people have been doing quite well, and then baby rev, more challenging. You can see quite a gap between, this is probably level 16 or 17, and here's level 19. So this is probably 19, 18, 17, 16. This is 15. So people have, there's a kind of a gap there. So grades per, if you look at how the grade distribution is from one angle, we have definitely the fewest A pluses on baby rev, but the most on embryo GDB. Of course, embryo GDB, I wasn't hoping it would challenge anyone. It's really a walkthrough to expose you to GDB concepts. Hopefully, then that in turn helped on baby rev. And then we have actually a reasonable amount of B's and so forth, but really you can see that no matter how you look at it, baby rev is the hardest module so far. I can't talk today. Anyways, and it's the same on this box plot. So this is the 25th percentile, 75th percentile, and you can see that it's very challenging. So the average on baby rev is something like 40 something percent, 44% right now. Not so great. But I expect, and of course, have no doubt that that number is gonna skyrocket. Where I want to see something closer to baby shell with this grading distribution, right? So baby shell had a lot of A's, a lot of B's, etc., etc. Actually, baby jail is a great distribution. Baby rev, you can still see the majority of people are failing, and this is like the 42% median or whatever. And in terms of actual grades, so if you weren't curving, we would have this layout. It's not so bad. A little too many people getting a D or an E. With the curve that I had announced before, a 1% curve, extending every grade bracket by 1%. We have this resulting distribution, which is much better. I have this scribble here because I think we have about 12 people that are in the class, but haven't dropped the class yet. This is based on basically interaction patterns with the website. People that haven't tackled Embryo GDB yet, for example, at all. Which would get us into a much more comfortable curve. So I think for now, at least, the curve won't change. It'll give us a more comfortable distribution, I meant. All right. So to summarize, Baby Rev is due on the 30th. Embryo GDB was already due. Everything else but Baby Rev is still doable for partial credit until December 12th. But obviously prioritize Baby Rev. Unless you haven't done Embryo GDB yet, then I'd recommend running through it to get up to speed. Cool. All right. Any questions on any of that? No questions. Let's see if there are any questions on Discord. There's a discussion about how thanks donation works. So, Charco, I was thinking we take your extra credit that you would have gotten and we just equally distribute it among all of the students. You'll be a hero of the people, and everyone would get some extra credit. All right. Cool. The Robin Hood of pwn.college, exactly. All right. No specific questions about this stuff. Let's talk about Baby Rev. Now, we have gone through, at a high level, Baby Rev 1 through 5, with dipping into many of them. We tackled Baby Rev 6. I did at least my instance of Baby Rev 6 on video, etc., in one of the lectures. We briefly explored Baby Rev 9, and I went through a full walkthrough of Baby Rev 12. And I believe Connor talked about Baby Rev 16 yesterday. So we can, I'll open it up to requests. And then we will, actually let's start with this question of, you can look at Baby Rev 14. Let's talk about Sinbotter. He said, how would you script Yon 85 when opcode of two instructions are hex 40000 and hex 400000? I'm confused about what you mean. If you want to elaborate, we can try to dive into that. Okay. Okay. It sounds like you might be confused on the... okay. Yeah, it looks the same, but there are different numbers of zeros in those numbers. Awesome. All right. Then David X Terror says that they feel like they cheated on Baby Rev level 9 because they only used one byte, not all 5. That's fine. That's the answer for Baby Rev level 10, I guess, right? you can achieve an enormous amount of changes in a binary with 1 byte, right? Especially in a license key checker. The 5 bytes were really there so that you could, for example, start out by changing the knopping out an entire instruction, an entire call instruction, or something along those lines. I demonstrated changing instructions to nop when I was showing this off initially. Let me show this. All right. So let's go to. Oh, my computer died. All right. Let's open up. And we'll open up Baby Rev level 9, and I will show you a good place where, like one possible patch. There's insane amounts of combinations of ways to solve this, but we're going to just do this real quick so you can see one kind of neat way that doesn't change the binary too much. Let's recompile it and see how the logic works. So we have this checking the received license key. You have this memcomp. If it doesn't pass, if the memcomp returns 0, which means it's equal, you win. Otherwise, you get it wrong. Let's take a look in it in inline and see what's going on here, right? So you have the call to memcomp. You have the test and the jump, right? Now, if you wanted to be fairly lazy, let's turn on a couple of instruction bytes so we can see what we're changing here. If you wanted to be fairly lazy, you could nop out, just replace with 9090, the test and the jump, or just the jump, right? 2 byte patch, not a 1 byte patch. Still does the memcomp, and then you get to call your win, right? Why did we give you 5? I mean, all sorts of stuff. You could modify this to call a completely different function, nop out the call, just to give you as much kind of possibilities as possible. Let me catch up on what's going on with CSE 539. I don't even know what that is. Okay. Yeah. Someone changed the test to a comp. Why would that work? Comp EAX, not 0 should still be the same. Ha! Someone's suggesting you can, in this offset for the expected result. So this offset is actually... No, come on. This used to be so easy. Do I remember the hotkey? No. Anyways. No. This offset is referencing expected result, but it's actually an offset in the binary. The offset is somewhere like this is the offset from RIP. It's a rip relative load. And you can change this offset so that it loads something else, for example. Or there's a lot of tips and tricks in the chat, but basically, once you start, I mean, if you're able to patch binaries, right, you'll reverse something enough to understand how to patch it. There's an enormous amount of stuff that you can do. Even as you've learned or will learn in Baby Rev level 11, even when the binary tries to stop you. Being able to modify binaries gives you a lot of power. All right, let's move on from 12 and talk about, there was one, Baby Rev 14. I think this is a good, or we can talk about approaches for full automation. Baby Rev isn't designed to be approached with full automation. It's designed to go and reverse engineer things painfully. If you're interested in full automation, there is a different module on last year's pwn.college instance. We won't cover it this year because I am actually building an entire course around it called Baby Auto. The course that we're building around Baby Auto that was going to launch again next semester, but embryo yawn is coming. But that course was going to be a more permanent version of the vulnerability research class that I ran last semester, where the students actually picked real-world software and found vulnerabilities and got CVEs and wrote proof concept exploits and stuff, which is good stuff. Someone, Shrek3Donkey says that the offsiders from yesterday, Connor covered some of that automation that you are looking for. I wouldn't approach, well, depending on what automation he covered. If you're talking about better Gdb scripting, take a look at those offsiders. If you are talking about automatically solving these challenges with something like the Anger binary analysis framework, I would be careful about that. Relying on automatic reversing at this stage will rob you of valuable reversing experience that you need for the next modules, because the future modules won't have source code either. All right, let's see. Question on Twitch: do I plan on teaching that vulnerability assessment class again soon? Yes, the plan was to teach it again this upcoming spring. But I am having a second child in December, so that's not going to work. So I'm trying to figure out other routes. I haven't figured it out yet. So probably one of two things will happen. Either we will teach it next fall alongside the first half of a split up, a pwn.college, like a CSE 466 that's split into CSE 466 and some other advanced class, or we'll it'll just have to wait until spring 2023. Exactly, Baby Yawn level 2. Yeah. Interesting. Do I recommend the Python GDB module? So, a couple of years ago, I showed off a method in GDB to basically automate using Gdb scripting the early challenges, like Baby Rev level 6. I wonder if I should do something like that to give you guys a bit of a Gdb scripting. Okay, let's check out that beautiful T, but also let's check out. This might be a good idea. Might not be a good idea. So we have level 6. That yeah, there's a question on Twitch. would the advanced classes be 500 level courses? Yeah, the way that I did this with my 500 level courses, for those that don't know, are graduate courses at ASU, but undergrads can take them with approval of the instructor. And the way that I did that for my the vulnerability research class was exactly that. It was a 500 level course. The undergrads could take it as well. Okay. Let's take a look at automating level 6 with GDB. Did Connor already do this? Can someone tell me? If yes, we'll just will the advanced course also be on Twitch? Yeah, any course in this format is going to be on Twitch as well. The with the exception of the actual vulnerability research part, I couldn't figure out a way to have that on Twitch safely, because oftentimes in class we were talking about unpatched 0-day vulnerabilities in real software. So probably what will happen is, instead, the VR class will have, you know, maybe half of the content streamed, like the actual pwn.college modules that'll comprise it, and then the Q&A about those modules, and then the actual VR part of it will not be streamed. All right. Okay, I see what Connor did. Okay, cool. So let me take a quick look at level 6 and automating it for you. Actually, I've already downloaded it. Here we have 6.1 is of course the version of 6 without the helpful output and all of that stuff. So here we are. This is Embryo.io 6.1, and in 6.1, Embryo.io, Baby Rev 6.1, and here I have, we have no symbols, but what we do have, of course, if we decompile start, is the first argument of libc start main, which is main, and IDA knows this so well that it just renames it to main. Awesome. So here we have main, and in main we have this call to read, where we read our let me add addresses. This call to read, where we read in our input, and our input here is 17 bytes, and then we have this memcomp, which compares our input, or this test, says did we get it wrong or did we get it right. And we have some crazy amount of stuff in the middle, right? So let's say, hey, I don't want to do all of this crazy amount of stuff in the middle. All I want to do is figure out dynamically, using Gdb scripting, the input that goes in here. All right, let's take a look. Of course, as I said, I don't recommend you automating it, but if you have already gotten past this should help you get more familiar with GDB. All right, so background IDA, GDB Baby Rev level 6.1. What do we do? Well, we're gonna break on read, we're gonna break on memcomp, and then that's really what we are, the two things we are interested in, and we're going to let's run. We have our breakpoint on read, continue, it reads in, our breakpoint on memcomp, continue, boom. Okay, so now we have these two breakpoints. So let's start scripting. We know that there's 17 bytes. Let's do things. Let's write something that just recovers the last byte, right? Sort is gonna make this problematic, but here's a better idea. Instead of blocking on read, knowing that things aren't so simple, let's if you were in my office hours when I solved this manually, what we did was go step by step, and I implemented a reversing in Python, every step in reverse, and got the flag that way, or got the key that way. Let's do the same thing. Let's start with implementing this in reverse, so that we'll recover what the value has to be here in order to get the right value here. All right. We know what the value has to be. It's this. Let's change this to a 17-byte char, and then we will edit, export data. So this is our desired solution. We're going to do this byte by byte. In Gdb scripting, it's going to be a massive pain in the ass, but let's do this in should we do this in Python in Gdb? I really want to show it to you in Gdb scripting. Let's just do it one byte at a time in Gdb scripting. Okay, so let's disable breakpoint 1. We'll keep breakpoint. Actually, let's disable breakpoint 2. Let's take a look back in okay, so this is the data we want. I'll just copy it off here somewhere. Perfect. Okay, cancel. Let me catch up on. Oh, okay. Nothing crazy on Twitch yet. Let's go back here. So we're going to start here. No, that's for this guy. We're gonna start here. Yes, okay. Perfect. So we're gonna break. All right, that's the beginning of that last something. I'm not even gonna bother reversing. Of course, it's an XOR, and here is the end of it. Okay, and we know that at the beginning, if we hit run. Our license key, let's just give it all A's. Of course, whatever it didn't read ended up getting read by Gdb, unfortunately. Okay. If we go back here, where is our buffer? Our buffer is, according to IDA, let's see where we read it in. Here's the read, here's the buffer. The buffer is RSP plus hex 30 or RBP minus hex 20. And we can see here, (17As), RBP minus hex 20, 17As. Same address, right? So our BP points to the right side of our, what's it called, of our stack frame. RSP points to the left side. I'm going to use RBP because it tends to be more stable. If you have base pointers in a program, they are not going to change. But if you have stack pointer could shift a little bit throughout the execution of a function if you have dynamically allocated stack variables, which can occur. If they don't occur in these challenges, but they can. So we're going to go off of the base pointer to script this insanity. And we're going to brute force just that first byte that we need to input so that its output is these bytes that we expect. Okay, so let's say expected it's this string. We're going to hex encode it. Let me zoom that in since we don't need IDA right now. And you should probably generate these automatically because this is an error-prone process, but YOLO. All right. Here is our expected variable, and as expected, of course, Gdb uses octal encoding instead of hex encoding by default, which is a disaster, but the printables match up. Here is this ASCII 3.6 is a 6, ASCII 3.2 is a 2. Here it is. 09 is a tab. 3.8 should be an 8 somewhere, but I don't see an 8 here. But I do see this 2A, this asterisk. Where's my hex 3.8? Okay, here's 02. Hex 3.8 is becoming 7.0. Okay, that's weird, but whatever. Let's just confirm that that is correct. Okay, I don't know why it didn't print me my 8, but it's there. Okay, so that's what I am expecting. Can I do this? Yes. Okay, perfect. And I can seek into this in Gdb. So as you can tell, every time I write Gdb script, there's a little bit of remembering that happens. So here's what we're going to do. We're going to break at the beginning of that code region. At the beginning of this code region, and that was our breakpoint 3, we're going to set that first letter to something, and we're going to run it and check at the end of the code region if that's correct. All right? And this is going to get insane. So how do we do this? Well, first, we need a reasonable program state. How are we going to get to a reasonable program state? We're already there. We're in breakpoint 3. Everything is initialized to our reasonable program state. Okay, so now we're going to create a function called brute force. Function brute force. And again, as you can tell, I have to remember this. Index. Nope. Help function. Ah, is it defined? It's defined. Okay. Okay. Let's do help define. Every time, man. All right. Define new command name. Command name is argument. Oh, okay. And arguments are implicit variables. Perfect. Define root. Let's see. Run once. Okay. What are we going to do? We're going to say we're going to set our IP so that we can just run this in a loop. We're going to set our IP to this same location at the beginning of that XOR. Okay. We're going to set the unsigned char pointer of RBP minus hex 20, was it? Yep. And we're going to set it to plus the index, which will be in arg1 to arg2. Okay. we're going to let's see if this flies. Well, for now, let's just do continue, or yes, continue. Yes. Okay, perfect. So we set the index to the right value. We continue, hit end. Okay, now we can do run once, index 0 with value 0. Missing argument 2 in user function. Missing argument 1 in user function. Ah, that's right. It's this insane format. 0. Is it run? Let me, I'm not above Googling for things, obviously, and that's what we should do. Gdb Custom Functions. Define, and then running. Example, here's the define, here's the defined. Define prefix, that's not what we want. Define adder, that's all good. And to execute, adder 1, 2. Ah, it's arg0, arg1, arg2. Okay, of course it's arg0, arg1, arg2. That's such a, all right. New mistake, redefine command. So what do? We jump to the appropriate place. We set the correct index to the correct value, and we continue. And we end. Okay, now I can do run once, index 0, value 0. Boom. And let's disable breakpoint 3. All right, now we're in breakpoint 4. Let's take a look at what our data has become. So this started out as all A's, and it ended up as hex 59, hex 31, hex 29, 18, 31, 29. Now, why is this 59? That's because this got set to 0, and as a result, it got XORed with apparently hex 59, which is in fact the first key, the first XOR key. So we have this run once. Let's see what our actual goal is. Our goal is ASCII 6, right? Can we do PX? Yes. Hex 36. So we got hex 59. We wanted hex 36. No problem. Let's just keep going. Run once. Now, of course, since we know it's XOR, we could easily do this without brute forcing. But because we don't know it's XOR, we can print out what we got. Okay, 59. If we give it a 1, how does that make sense? Oh, oops. That's the index. This is the value we're trying. What? Six, 4, 6. Why did this not change? Maybe our state isn't as nice as we thought it was going to be. Oh, yeah, we're getting a little too into the weeds here. We stopped here, and we kept jumping back in. Sorry, we started here with our brute forcing little script. This, and we had it break here and set RIP to this to start over. This uses this counter. It's in the middle of for j equals 0, j less than 16, j plus plus. We need to redo j equals 0 every time that we break. So it needs to be at 1.5 AB instead of 6.4.6, which is where we did break. So let's do define set of 6.4.6 5 AB. Then we set the thing, we continue, and okay, now we can do run once. Let's see what it looks like with a 0. Again, it's going to look like, yeah, 59 with a 1, 58. Makes sense, right? We basically XORed a 1 with that, with a 2, 5B. Okay, so now what do we want to do? We want to keep running that until we have successfully brute forced that byte that needs to be input into that value in order for it to the byte that needs to be there in order for the XOR to output the correct thing. Let's take a look. So we have our run once function. We want basically run that over and over and over until we brute force the byte, right? So we can say define brute byte, and then we take the offset as the index there. And what we're going to do is we're going to set guess to 0, and then we'll just, oops, my bad, hold on, that doesn't make sense. We'll set guess equals 0, and we'll iterate while guess is less than 256. We'll iterate to the whole byte. We're going to run once arg0, the index with our guess. And if can we run once might have to change a little bit, but okay, if this is getting a little out of hand, but let's just power through at least this part. If unsigned char stars, the dereference of the character at the offset into our process string is equal to expected, the offset into the expected, then we break. No, how can we GDB break out of loop? Because we can't just use no, GDB break out of loop in defined function. Lol. GDB while define while break. OMG. Okay, let's do this. Nice and easy. Correct equals guess. Guess equals 256 so that it exits. We can printf found value for offset 0 or for offset d x, and this will be arg0 and this will be correct, and then we end. Okay, and then we end. All right, let's see if this looks reasonable at all. Brute byte 0. So we're brute forcing the byte. Oops, I forgot to add 1 to the byte. We're brute forcing with byte 0 all the time. All right, so let's try this again. Yes. Set guess to 0 while guess is less than run once. Check the result. Right? Yeah. Check the result. Set the correct. Set the guess. Print. And the if. Otherwise, we set guess equals guess plus 1. There we go. Okay. And then and. Okay, let's try it this way. Let's brute byte 0. Oh, I broke something. I didn't do set correct. Oh, God damn it. Anyways, it worked, guys. It found the correct value and then it crashed because my script had an error. I wish there was a way. There's got to be a way. Gdb edit define in Vim. There's got to be a way. Yes. Yes. Look at this. Look at this. Edit. Brute. Is this for real? Brute byte. No. Edit function. No. No, it's a lie. Okay, anyways. Wouldn't it make sense to use a script.gdb to do this? Oh, you're absolutely correct. See, this is why sometimes we go down insane insane situation. How can I get the source with my functions? Info functions. Oh God. Info define. Info. Line locals macro. No. Oh, and I scrolled way too far. Okay. Yeah. Gdb print define function. No. Show. Yes. Show user. Aha! Thank you, Ethan, for saving some sanity here. So define brute bytes I don't know why I didn't do this from the beginning. This is insane of me. Let's just here, indent things here. We're missing an end. No, we're not. Yeah, we are. Okay, define run once. Okay, here we're going to break at read with the commands. Actually, let's do this. Instead of breaking at read, we're just going to behead the program. We're going to break at the call to read. We're going to give it a command to we're going to just mem set everything to 0. I think that hopefully this will work. Yep. Okay. Mem set everything to 0. Then we're gonna continue. No. Gonna skip the call to read. Okay, and we're gonna continue. Okay, then we're going to break at actually, let's go here. Okay, guys, we went way. Oh my God, I can't stop. It's an insane tangent. I can't stop. All right, we're going to do. We're gonna break at read, and then we're going to execute just this last bit to figure out what should we have read in order to successfully pass just the last check. So instead of continuing here, we're just going to brute bytes 0. It's gonna be beautiful. This is gonna call run once. It's gonna jump forward to that last check and execute it. All right. Now there's one thing that I needed. Yeah, this has to be set. This is to be set. And now if you run this, gdb-x script.gdb baby rev level 6 error in source 21. Argument required, 1 or more breakpoint numbers. Can we do that? No. God damn it. Can we do this? No. There's a way to do this all in one line. Anyways, it's fine. Ah, there's no mem set. Okay. Set RBP minus hex 20. What do we want to set it? It's going to be an unsigned char star. Will this even work? Can we do this? Set. Well, we'll just pretend that we can do it. 22. No registers? What the fuck are you talking about? Ah! Oh my God. It's all because I'm missing this. This will work, of course. Okay. Yes. We're in breakpoint 1. All right. Why are we in breakpoint 1? Oh, no, we set breakpoint 1. All right. And then, of course, we just say run. Okay. Boom. Wrong. No flag for you. Why? Because I did a continue, but instead I actually want to run until the code is done checking my thing and actually prints here. So let's 1650 is where I want to run to. Base plus 1650. Do I need a start here? We'll find out. Yes. Boom. All right, let's see. Error source 28. What? Breakpoint 1. And then the until doesn't work. Here we start debugging. It didn't. Oh my God, thank you, Ethan. Okay. 29, invalid argument syntax. What? No, come on. Okay, we're just going to do this, run. Invalid argument syntax. Where? In printf? No. Yes, okay. The printf. Need commas. Sometimes you need commas, sometimes you don't need commas. Really, you should do this in Python. Okay, trying 0. Cannot subscript something of type void. Okay, I never set the expected. That's my bad. That's on me. Okay. We're getting there, people. I forgot we need new lines for printf. This is insane. Ah! Okay. The value to succeed for that to XOR with 5.9, 6F. 6F XORed with 5.9 is 36. Amazing. Okay. Let's real quick. I know we just said we'll just brute force 1, but now this is brute offset. And if we really want to do brute bytes, of course we can. There's no problem with that. Define brute bytes. Set offset equals 0, while offset is less than 17. Brute offset, offset, and offset equals offset plus 1. Boom. Okay, and now we can brute all of the bytes. Let's run it. And we hit run here. Okay. Boom. Found an offset for every value. Of course, we didn't save them anywhere. How do we save them? Let's look. Gdb string concatenation. Concatenate GDB variables. Oh my God, you have to use eval? No, come on. Okay, this is shockingly hard. What the fuck? Printf won't work. Variable as a... Okay. No, I know what's going on. Okay, expected. All right. Here's what we're going to do. All right. We're going to say brute force that last step. We're actually going to start with all zeros, and then when we brute byte, we're gonna say, can we return values from GDB? Nah, this is impossible to search for. We're not gonna do that right now. We're going to say, we're going to pass in the correct, or let's say answer. Gonna pass in this variable. Hopefully it passes it by reference. I have no idea. This is a little bit crazy. This is just too crazy. Gonna pass it in here. arg0. In brute offset, we're going to say set arg3 arg0 equals correct. Will this work? Who knows? Who the hell knows? Let's give it a try. E44. No, that's all the way down. Missing argument 3 in user function. So brute bytes. Brute bytes calls brute offset. Brute offset arg2, not arg3. What? Oh, yeah. Brute bytes offset arg. Yeah, I don't know. Offset and arg0. Arg0 is our answer. This is a disaster. Run once. arg0. Oh my god. Until here. Where are we going wrong? What's missing argument 2 in user function? Oh, this is arg1. Okay. Damn it. Oh, no. We don't need correct. We need answer. Answer. Yes! Look at that. That XOR'd with whatever the hell, with that rolling XOR that we didn't even bother reversing is exactly the correct answer. So, okay, hold on. Now we're really amped. We just brute forced that whole thing with this. Let's take a quick look. This is insane. Okay, let's take a quick look at the rest of the code. What happens here? This is a reverse, and then this is a swap. And at this point, we know what we need to insert in order to have this. What we need to have here at this point, specifically at this point, in order to get the right answer then. So now we can redo that exact thing to brute force what we need to have at this point. What answer we need here, or what we need to put into the read to have the right answer here. That is a little trickier because things get shuffled around, and we're not going to do this live, but what you saw in my GDB script solution is basically a, let me zoom out a little bit so you can see the whole thing. It's basically a brute forcer written in GDB that just yields the control flow to the beginning of what we want to brute force, runs it, and then keeps doing that over and over and over. Right? Very crazy stuff. Yeah, that was a painful lesson, but hopefully useful, as someone said on the chat. All right. Okay, let me see. What did I do? Brute force involves. I didn't see my GDB code. Yeah, sorry, Ethan. I missed your GDB comment. Oh, you can set GDB. I didn't know this. See, you learn something new every day. What did I? How? If we. Okay. So by default, GDB will string set this in octal. If we do radix 16, no, set radix 16. No. Let's see. Scrolling up. Okay. Cool. All right. Anyways, yeah. So this is kind of an advanced crash course into GDB. Hopefully, it is useful. Maybe something that we should do for an embryo GDB level. All right. Are the later Yan 85 levels fully solvable through GDB? No, absolutely not. In fact, I would caution you for relying fully on GDB at the expense of actually understanding code for the later levels, right? So GDB is an amazing tool, and like you said, Act 466 interaction has been using GDB as a supplement to determine things like opcodes, args, registers for their disassembler. That's absolutely what you want to do. You can also write a disassembler in GDB, right? You break in the interpreter loop, and then you actually disassemble it there. You can, in fact, if you're very clever, let's take a quick look at level 16. My lights are off. Why are my lights off? Hey Siri, turn on the lights. Starting to get dark. Okay, let's take a quick look at level 16, which is the first level where the Yan code is actually encoded instead of not encoded, instead of written out in C. All right. Level 16, practice. I turned on other people's lights. That's awesome. All right. Oh man, it didn't save. Okay. Okay. Download this. Boom. Okay. Baby Rev level 16 is ask for the key. And if you actually open it, if we actually open it, wait, did I do level 16.1 by accident? No, let's do 16.0. Just so we don't have to deal with, you get to deal with the lack of symbols. Okay. Let's open it. 16.0. Screen. I really wish it didn't resize everything. Okay. Boom. And there we go. All right. Let's see what's going on here. Right. What's going on here is it prints a bunch of stuff. Then it mem copies something called VM code of length, VM code length. It hits the interpreter loop. Connor talked about this last time, right? And then the interpreter loop will run and say and do interpret instruction, and the interpret each instruction. The interpret instruction will check to see what the what's it called? What encoded instruction for every what the instruction that is encoded for every snippet of yarn code. Sorry, it's getting kind of late in the class, so I'm starting to lose steam. I need to hydrate. The yarn code is processed one instruction at a time. Each instruction is decoded to figure out the operation. Each operation then is called and grabs its operands to actually perform the operations it needs to perform. In teaching mode, it prints out a trace. But you can print out the same trace with GDB in testing mode as well using Gdb scripting, right? So we can create, so this was script for level 6. We can create a script for level 16.gdb, and we can do something that is kind of similar. Let's just start out Gdb scripting. Of course, this is redundant in teaching mode because we already have it, but in testing mode, it'll be useful. And we'll start out, we're going to break on interpret immediate. We're going to print out our own trace of the yarn code. We're going to say, hey, immediate blah equals blah. And to do that, we're going to use, well, we won't have describe register in the other ones. We're just going to at least print out the arguments, and then we can do better and better as time goes on. Okay, let's, so we're going to break on interpret im. It looks like the, in my version of this, the least significant byte, the rightmost byte of the second argument, which is passed in RSI, is going to be to encode the register used. And then the second byte, let's actually take a look at the assembly to be sure. No, the third byte is going to, the third from the right byte, which in Little Endian is the third byte, is going to be used to encode the value. So let's take a look here. We're going to break in interpret im, and we're going to say set val or set reg selector equals al, and we're going to set val equals eax shifted right by 2 and anded by oxff, so that's the value. And we're going to print our trace immediate x hex for now. And we're going to add the reg selector and AL. Okay, and we'll continue here. We'll just run this whole thing. And when we run it, gdb-x, script 16, baby rev, level 16, 0. We run it. Error source file value can't be converted to integer. We fucked it up. So first of all, we need a new line here. And now we're going to use our Printf Debugging power to see what's going on. No, harsh trace. Okay. Ah. Huh. It's partway through the printf. Okay. Let's remove. Just make sure that that's not a problem. It's not a problem. It's this reg selector. No. Why did we do AL? This should be val. No. Okay. Let's print this out. Maybe it doesn't like AL. No. Why can't value be converted to integer? I'm gonna go crazy. Okay. Let's see if it works with just zeros here. This should work. Okay, this works. Our trace is good. Now, reg selector. That works too. And why doesn't it like reg value? Maybe the name is bad. The name was bad? Interesting. Okay, don't use the name val. All right. And now, as you can see, we have our own trace going on. So we have... What? But our own trace is incorrect. It's always 50 and it's always 14. That's not nice. Let's take out any risk of weirdness from architectures. Okay. What the fuck is going on? B equals 30. Okay, sometimes it's a little weird with types here, but that would surprise me if that was the problem. No. Oops. What the hell? Oh, what am I doing? Why RAX? Thank you. It's RAX because I get tired too, guys. I get tired. It's RSI. Thank you. Oh my god. Okay. Here we go. Hold on. I'm going to put you on mute and blow my nose. All right, I'm back. Boom. All right, here we go. Immediate. Is it RSI? A2. A2 is RSI. I know what's going on. No, I don't. Second argument, yes, RSI. First argument is the VM state. So RSI, right when we RSI, and it should be its least significant byte. Okay, here's 08, and you can see it's always stable when we hit im. Okay, that's good. And this is a equals 1. Here's the 1. I'm an idiot. What does this do? It shifts right by 2 bits, not 2 bytes. Oh, man. All right. There we go. So, immediate for B, here it is, C equals B. Immediate 10, 1, A equals 1, right? And of course, with this output, we can know that A is 10. But how do we know that A is 10 in reality? That one is a little trickier, right? So what we can do is we can use GDB to read out a trace, or to print a trace of all of this. And as we reverse things in IDA and understand what variables are what, we could understand or what encoded registers are what. We can understand what they're doing a little better. The other way we could do it, is reversing, finding the right register. So this is A, this is B, this is C, right? So let's double check that case 4 is C. And why am I saying that? Because, you know, from a previous reversing, hopefully by now you realize that in memory they're all ordered, even if the encoding is random. So let's find a 4. Yes, 4 is indeed C. So now what we can do is write a quick GDB script to analyze right register and understand whether let's see, we could even do this in an insane way. In an absolutely insane way. Do we want to do this in an insane way? What do you guys think? Let's do it a crazy way. Just one last hurrah. We're going to, using GDB, figure out which register this is. It's going to be insane. Okay. All right. I apologize in advance because I'm sure this will be insane. So here's we're going to define. We're going to define insane. And we're going to add. All right. Here's our insane function. Here's what we're going to do. We're going to break in right register. And of course, or no, we're going to set rip to can we do this? Let's see. Yes, we can. What the fuck? Why are we in read register if we set rip to write register? That was weird. Okay, anyways, we're gonna set rip to write register. We're not gonna worry about what just went wrong. And we are going to can we pass the location until past the current? Ah, damn it! If we could make multiple untils, we'd be golden. Okay, no, we can't. Well, can we do this? Oh. Oh. Okay. No, we can't. All right. So how are we going to do this? We're going to break. We're going to start executing this program, this function, and we are going to okay. This function takes an argument, a1, which it uses as to offset into to set registers. So all we need to do is provide it some allocated region. So here's what we're going to do. We're going to make this into a different GDB script. And we're going to break in main. And we're going to go to... we're gonna break an interpreter loop because that's where. Okay. Here, our structure for the virtual machine is ready. Okay. And in this interpreter loop, we're going to do something crazy. We're going to let me look up the 4 syntax. Gdb4 syntax. Can we do 4 in GDB? Come on, I don't want to do while. Fuck it. Okay. We're gonna say encoding. This is crazy. All right. We're gonna define a command called test encoding. And this command will take a encoding in an argument, arg0. And here's what we're going to do. We're going to set rip to write register. No, even better. Let's do read register. Why are we doing write register like insane people, right? Sane people will use read register for this. Why? Write register modifies memory. That's just gonna be a big pain in the ass. Read register is just gonna read memory and return it in RAX. So what are we gonna do? We're gonna call read register. And we're not even gonna set rip to anything. We're gonna call read register. And what does read register take? Our A1, so we'll give it RDI, and an A2. And what's the A2? A2 is what we want to figure out, right? And that is our encoded arg0. And then if RAX, first we want to set up, so here's our idea. Set names to the variable, to the registers, so like ASCII names. So check this out. This is a cool hack. We're gonna set the unsigned char star of A1 RDI, okay, to 1024 offset 1024 is A, and so on. B, C, D, and I don't remember the other. I think it's S, F, S, S, F, I. But you know, you have to do some reversing to figure out how this what's going on here. Oh, Ethan is already talking about read register. That wasn't great idea, Ethan. 7, 8, 9. 3, 0. Okay, awesome. Then, so we do this crazy set. Then we call the read register, and then we will just printf register arg0 register x is C. arg0 rex. Okay, let's hope this works. So in the command interpreter loop, we're just going to do test encoding of 0x1. 2, we know it's a bitmap. 4, 8. Let's do 0 here. And this will be all the ones. Oops. God damn it. Okay. And then we run. Let's see what this is like. Read register as unknown return type. Cast it to figure out the return type. Let's do this. Can we do this? No symbol call. Oh, yeah. There. Okay, cast, that's fine. Sure. Program debugged exited while in a function call. Because, did you see that? We forgot a new line. Run this. Register 1 is I, 2 is F, 3, 4 is C, which we know is correct. 8 is S, and then crash due to unknown register. Okay, and that of course is this nonsense here. So let's just remove this call to crash and return something instead. This call to crash is at 1549. So let's do this. Break base plus 1549. Alternatively, if you don't want to, well, yeah, let's do that. Commands, we will set RAX to X, the character, then return, then continue, and then end. All right. Evaluation read register would be abandoned. Program being debugged stopped while in a function called from GDB. I see. So we can't have a breakpoint. Yeah, that kind of makes sense in this call. That's a bummer. What's an elegant way to do this? Well, that's fine. We'll just won't. We're humans. We're not robots. We say, okay, crash due to unknown register at the one after OX8. We just comment this out. Oh, also, this is complete stupidity. I really fucked that up. There we go. That's what we meant to do. Okay, still unknown register at 80. We can comment that out. And now we know all of our registers from GDB using understanding in IDA, but then being able to translate this script to other levels as well. Cool stuff, huh? Yeah, Genesis. I need to look at Twitch more often. Yeah. Cool. All right. Using GDB, of course, in Yan 85, you can help with certain things. Of course, this GDB route initially was longer than just taking a look at here and figuring out that, okay, this is A, this is B, this is C, this is D, this is E, or there's no E, and so on, right? S, F, I, or whatever. The advantage of the GDB case is it's kind of, with more work, it's automatable to other Yan 85 instances. But the advantage of reading this out is that it's faster. Cool. So that's one kind of step toward level 16. Of course, we will have office hours again tomorrow and talk about more baby rev insanity. Until then, I gotta run. Good luck. And I hope to see everybody at the top of the scoreboard. Have a good one.